Hello and welcome back to Bioclass Bytes. In this video, we are going to talk about Earth's internal structures. Don't forget to subscribe to my channel and like and share this video. These are the unit and lesson titles for this video series, and in this video, we are going to focus on Earth's internal structures. In this video, we are going to talk about the three parts of Earth's interior. So this illustration was taken from geology.com. I will provide the link in the description below. So one good way to visualize the three parts of an Earth's interior would be visualizing cutting a fruit in half, specifically a fruit with a big seed, such as plum, peach, or avocado. So the outermost layer, the skin, is your crust. Then the juicy part of the fruit is the mantle, and then the big seed is the core. This illustration shows us the structure of the Earth's interior. So you have your solid inner core, followed by the outer liquid core. Okay, and these two are both made up of iron and nickel. Okay, above that you can find the mantle, which is made up of high density rock. You have your lower mantle, solid lower mantle, and then you have your upper mantle. Okay, and then above that you have the crust, very thin crust, where you can find most of the Earth's landforms, okay, and land features. If you take a quick look at the cross section of this part of our planet, you can find the transition zone from lower to upper mantle, then a stenosphere, a solid portion of the mantle but actively moving, so very mobile. Then on top of that, you have the lithosphere, the solid and rigid rocky part of the crust. You have your two types of crusts. You have your oceanic crust, so that's below the hydrosphere, below the bodies of water. So it's quite thinner compared to a relatively thicker continental crust, okay, where you can find most of our landforms, okay? And above that, you have the atmosphere. Okay, so let's look more deeply into the different layers of the Earth. So you have here number 1 and 2, your continental and oceanic crust. Okay, so that's mostly made up of your lithosphere. So this is relatively cool and made up of rigid shell. This is what I was talking to you a while ago. So the continental crust, so that's the land portion or the continental portion of the Earth. The oceanic crust, that's found beneath the bodies of water. So right beneath that is the upper mantle, your asthenosphere. So this is beneath the lithosphere. Okay. So here, a small amount of melting in the upper portion mechanically detaches the lithosphere from the layer below, making the crust move independently from each other. So the asthenosphere is the reason why the plates are moving either towards, away from, or against each other. So right below that, the mesosphere, or the lower mantle. So this is layer number 4. So this is where rocks are very hot and capable of gradual flow. The next part will be the outer core. Okay, this part, composed mostly of iron nickel alloy. This is a liquid portion of the core. It has convective flow, and this is the part that generates the Earth's magnetic field because of this alloy composition. Then the inner core is stronger than the outer core, mostly based like solid. So in terms of thickness, as you can see, the crust is just very thin, within 30 to 65 in kilometers in thickness. Then your mantle is quite thick, with around 2,800 kilometer thickness, and then your core is also quite thick. Of your outer core with 2,200 kilometers, and your inner core with 1,200 kilometers. To help us visualize the distance from each other, use this analogy. So for example, this is your school, and then this is a famous mall near your area. So a bus ride will take you 9 minutes to travel from your school to that market. Okay, so it takes the bus 9 minutes to cross that 2.6 kilometer distance. So with that analogy in mind, so for every 2.6 kilometers, it takes the bus 9 minutes. So we will use this measurement 50 kilometers as our basis. So how long will it take for that bus to reach to cross 50 kilometers? So that will be our x. So using cross multiplication, we'll try to determine the value of x. So 9 times 50, that gives you 450 kilometers with per minute or per minute. And then to get x, we will divide that with 2.60 kilometers. So divide, so that the only remaining value will be minutes. So 450 divided by 2.60, that gives you 173 minutes or 2 hours and 50 minutes. So that's the value of your x. So for every 50 kilometers, it takes you around 3 hours to travel. So let's go back to that measurement again. So if you're going to travel via bus with that velocity, how long will it take for you to cross the different layers of the earth? So for the crust, with this distance and with that velocity, it will take you from 1 hour and 45 minutes to 3 hours to 45 minutes just to cross the crust. Now, to travel along the mantle, it will, with that velocity, with that bus ride, it will take you 6 days, 22 hours, almost 7 days, just to cross your mantle. Then to cross the Earth's outer core, it will take you 5 days and 10 hours just to travel this distance. And then to cross the inner core, it will take you 2 days and 22 hours, almost 3 days. So how long, if you add this all up, how long will it take for you to travel from the Earth's crust down to the center of the core with a bus ride following that velocity? So it will take you around 3 days plus 5 days, so that's 8 days plus 7 days, so that's 15 days. So more or less 15 days. With a bus ride with that velocity, it will take you 15 days to reach the center of the Earth's core. So I've mentioned that there are two types of crust. So you have your thin oceanic crust. It's considered thin because it's found below the bodies of water and there's water above it. So it's relatively thin compared to a thicker continental crust, which is where the continents are found. Thus, continental crust, this is where our houses are built above or built on. And then oceanic crust, they're found below oceans. So the thin oceanic crust is mostly made up of basalt, while the thicker continental crust is mostly made up of granite. Okay? So the low density of the thick continental crust allows it to float in high relief than the density of the matter below. So that's the reason why um, the continental crust is supposed to be moving across or moving along the high density mantle. I will provide the link to to geology.com in the description below. So yeah, so the Earth's mantle is thought to be composed of olivine-rich rock. So there's different temperature along the different layers. Okay, so the upper mantle is mostly generally cool but made up of brittle substances, while the lower mantle is made up of soft substances or soft materials and are generally warmer. Okay, so then the Earth's core, the the outer core is made up of liquid substances, while the inner core is mostly made up of solid composition. Okay, so the core is the Earth's source of internal heat. We will discuss this in the second unit because it contains radioactive materials which release heat as they break down. Okay, so again, the outer core is made up of iron nickel alloy, while the inner core is solid even though its temperature is higher than the outer core. Okay, I recommend that you watch this video from It's Okay to Be Smart. Why does the Earth have layers? I will provide the link in the description below. That ends our video. I hope you learned something new. Don't forget to subscribe to my channel and like and share this video. Till next time, goodbye.